When learning to work with different bases, I recommend starting with base 5, and there are two reasons for that. One is because it's what I'm going to call a rather moderate base, and the other is that we can represent it with things that we're familiar with. So for instance, the place values we have are 1, 5, and 25. 1 could be represented with a penny, 5 could be represented with a nickel, and 25 could be represented with a quarter. So we can actually use physical objects to help us wrap our minds around this. And the other thing I mentioned was this being a moderate number. And what I mean by that is, if you were to start out with a smaller base, say 2 or 3, you would have so few digits to work with that you almost can't get up and running. And the more you work with bases, the more you're going to understand what I mean by saying that. If you work with a much larger base, something over 10, let's say base 16, which we call hexadecimal, which computer scientists work with a lot, well, you've got the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but the digits have to go up to one less than the base. You need to have 16 digits, and the last one has to be a 15. How do you represent a 15 with a single number? Well, you're going to have to use some kind of different symbol, maybe a letter or something to represent that. So here we have things that we're already familiar with. We're familiar with these 5 digits that are in base 5. And we have enough there to get up and running. So let's play with this a little bit. First, let's talk about counting and what that looks like. So we're going to see how to represent 1 through 12 in base 5. So 1 is just a penny. It's 1 in the ones place. And 2 cents is 2 pennies. And 3 is 3 pennies. So far, not so bad, right? 4 pennies is equal to 4. But what happens next, I'm not just going to keep throwing pennies in here. When I can exchange for a different type of coin, I am going to do that. So instead of having 5 pennies, I'm going to represent that with a single coin that has the same value, and that is a nickel. Notice that now we have 1 coin in the 5's place and 0 coins in the 1's place. 5 in base 5 is 10. It looks like 10. We call it 10. It's not 10, it's 5. Well, what is 6 cents? Wouldn't that be a nickel and a penny? That's equal in value to 6. We keep counting. Notice I'm adding 1 each time. I'm just adding 1 more. So after 6 comes 7, and I almost wrote the number 7, but that does not exist in base 5. So what I need to do is use 2 symbols. A 7 looks like a 12. It's 1 nickel and 2 pennies. And then we have 8, a nickel and 3 pennies. 9, a nickel and 4 pennies. Now we're kind of rocking and rolling, and we might very quickly just throw another penny in here, but wait, that would give us 5, and 5 pennies is equal to 1 nickel. So 10 is 20, and isn't 10 cents equal to 2 nickels and no pennies? But if I need 11 cents, then I could use 2 nickels and 1 penny, 2 nickels and 2 pennies for 12, and so on. One thing to notice is that I'm not using dimes. I'm not using dimes because dimes are not a power of 5. So that's maybe a little bit of a downfall for this system. We're not using all of our coins. Hey, you know, dimes are tiny. They tend to get lost. Let's just forget about them. We're going to use pennies, nickels, and quarters because we need powers of 5. So that's counting in base 5. Whenever you hit a 4 and the next thing is 5, that next coin is going to end up in the next column over. Moving on from counting to conversions, let's take a quick look. So let's say that you are asked to take 132 in base 5, 132 in base 5, and then turn it into a base 10 number. So that's what those subscripts mean, is that this is the base that number is in, and I want you to turn it into a number in this base. Well, a 1, 3, 2 is going to represent 1 in this place, 3 in this place, and 2 in that place. So let's see what happens. That's 1 in the quarters place. It's 3 in the nickels place, and it's 2 in the pennies place. And use what you know about money to figure out what that value is. We've got 25 and another 5, we're up at 30. 2 more is 10, that's 40. Plus 2 is 42. That's 42. And what this translates to, which is something you really need to know for when you're working with other bases and you can't use coins, is it's a process of multiplying and adding. I have one group of 25, maybe I'll even put that up here. Not sure how well you can see it, but one group of 25, that's 1/4. I have 3 nickels, which is 3 groups of 5, and I have 2 pennies, which is 2 groups of 1, and if I add these up, it's 25 plus 15 plus 2, which is in fact 42 in base 10. So when you're going from a different base to base 10, it's a process of multiplying and adding. But now we're going to go in a different direction. I'm giving you the number 89, our regular old number 89 that we've known and loved since we were little kids, and we're going to turn that into base 5. Well, we can think about that also as money. So if you need 89 cents and you want to use the fewest amount of coins possible, you're not going to slap down 89 pennies. If you're at the store and you're going to buy a little candy bar for 89 cents and you slap down 89 pennies, they're not going to be very pleased about that. So let's see. What's the smallest amount of quarters that I can use to get as close to 89 without going over? Well, I can't use 4 of them. That's $1. That would be 100. But I could use 3 quarters. Right? 3 quarters is going to be 75 cents. Now let's see, how much is left? I might even write, well, let's write it over here. So 89 minus 75, if I do the subtraction, that says I need 14 more. I need a value of 14 more cents. Well, 14, that's going to be 2 nickels. That gives me the 10. And then 4 pennies. And so let me go ahead and lay the whole thing out here. So 89 cents is in fact 3 quarters, 2 nickels, and 4 pennies. So 324 in base 5 is equal to 89 in base 10. And as we went along here, what I did, I'm always working with the remainder. I'm always working with what's left. So I had 89. I took out as much as I could in a value of quarters, left me with 14. How many nickels can I fit into a 14? Well, not 3 of them. That would be 15. 2 nickels is 10. And then what's left over is 4. Well, how many pennies do I need in order to make 4? That's 4 pennies. It really is the opposite of this procedure. It is division and subtracting instead of multiplying and adding. You're not seeing the division here, but think about it a minute. The first question I asked was, how many quarters go into 89? When we're talking about how many go into, you're doing division. 89 divided by 25 gives us 3. And then we have a remainder, and that remainder is 14. So I hope this helps as you begin your study of bases. Just really work with base 5. Count with it, convert back and forth with it, and that'll give you a really solid foundation for working with other bases. They all have the same structure, but at least in this base, we have something that we know about and feel comfortable with that we can use to help us understand.